Hi everyone, I hope you all are safe and doing good. So let's see one lead code question on DP. I will tell you how you will identify that this is a DP problem. Dynamic programming you can use here. How to identify that thing also we'll see. But first let's understand the problem statement. Climbing stairs. You are climbing a staircase. It takes n steps to reach to the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? Suppose n is 2. N is 2 means you have to reach like 1 and 2 here, here, and you are standing here. How many distinct ways are there you can reach till top? Here n is 2. N means it takes n steps to reach the top. Means basically you want to reach till top, right? So I can move one step. So I can move first here, then here. 1 plus 1. So I can reach till here. One way is this. Second way is, or you can take two steps, directly two steps. So I can directly jump from here to here. Directly two step. One way is this, and that's it. So there are two distinct ways I can reach from here till the top. So there are two distinct ways. Output is 2. There are two ways to climb to the top. You can take first one step, then again one step, otherwise two steps. Now suppose n is 3. You want to reach here. Here. 1, 2, 3. 3 steps you need to reach till top, and you are here. Now how many distinct ways are there that you can reach from here to here? You can take first again one step, second step, third step. One by one I'll take steps. So 1 plus 1 plus 1. One way is this. Next way is this. Next way is what? First I will take one step, then I'll directly jump 1 and 2, two steps, because I can take two steps also. So 1 plus 2. One way is this. Okay. Next way is what? First I will jump directly taking two steps to this stair, and then only one step I can take. So first two, then one. Apart from this, I guess there is no way to reach from here to here. With these given constraints are this. You can climb either one step or two step, and your objective is to reach till here. Yes, so some constraint is given here. So there are three distinct ways. There are three ways. Output is here. See, 3. So the problem statement, I guess, is clear to you. How you will solve this? Now you have to figure it out, and how this is a DP problem. That also you need to identify. Let's see. Suppose n is 5. The top is n is 5. You need 5 steps to reach till top. So means you need to 1, 2, 3, 4, 5. Means 1, 2, you are here. 1, 2, 3, 4, 5. And you need to reach here till 5. This is the top. Now how many ways are there to reach till here? So either you can, means you have to identify all the possible solutions, all the possible ways. You have to count, basically count all ways, all possible ways to solve this problem. Okay, that's one thing. I'm just telling you how to identify that it is a DP problem. How to identify? So whenever in question such kind of thing are given, like you have to count all the possible ways or distinct ways. Yes, it means you have to try all the possible solutions. It means we will use here recursion. Yes, because using recursion only you can find out all the possible ways we explore. We know this thing. Yes. Now, if there is recursion, that's one step. So one way is, first you need to identify that. How to identify recursion? Those are, you can say, those are the tips to identify it's a DP or not. So it's suppose recursion, but it's not that if the problem is of recursive problem, then definitely it will lead to DP problem. No, that is not always true. Sometimes the problem you can solve with recursion, but it doesn't mean that you can optimize that. DP is what? DP is nothing but you are optimizing recursion. Optimizing recursion. Because in recursion there are small sub problems, those are overlapping. So you can store the result of intermediate subproblems if possible and use that result. That is nothing but we are enhancing recursion. So that is nothing but DP, dynamic programming. But it doesn't mean that every time when you are using recursion to solve a problem, you can every time enhance that. That if the problem is using recursion and it satisfy both the properties of DP, that is first is overlapping subproblems. Second is optimal substructure. Means there are subproblems and you are calculating those or you are solving those subproblems again and again. Means yeah, you can use here DP. That's a sign. Right. So these are some ways. So first thing is in some question that's given like count all the ways, distinct ways, all the possible ways or steps, count number of steps or paths. First is this. Second is you will be asked optimal sometimes, minimization, maximization, because DP is used to solve optimization problems. So there you will be asked some minimizing or maximizing kind of thing. Maximize profit, minimize cost or minimize time or like that. Okay. So that is one more thing that you are being asked optimal solution. Okay. Then you can identify that, yeah, it may be a DP problem, but you have to figure that out. Also, there are chances that if these are the things, means first is recursion, and in that recursion also, it should have overlapping subproblems and optimal substructure. Generally have overlapping subproblems, so means you can solve that with DP. And when recursion will have those overlapping subproblems, when this recursion in that particular function, you are calling the recursion two times. Suppose you are calling recursion only one time. It means the problems, subproblems will not be overlapping. But if you are calling recursion two times, this and this, then again this and this kind of recursion tree is there, then yes, there'll be overlapping subproblems. Because you know now how recursion works. We first move this. Then whenever we reach till dead end, base condition, then we return and explore the right path. Like we return, explore the right path. So maybe we have solved this thing previously. So this is overlapping subproblem. Like in Fibonacci series, you remember this thing, right? So that are some points you need to identify or some keywords, right? You have to choose from choices or minimization, maximization, count number of ways, distinct ways, steps, paths. These kind of keywords will be given to you, and you have to identify it's a recursive problem. If it's a recursive problem, then you have to identify subproblems are overlapping or not. How you will identify that thing? Generally, when recursion, you will have two calls like that. The problems will be overlapping. Subproblems will be overlapping. So that's a DP sign that you can use DP here. Okay, that's how you will identify. Okay, so one by one, when we discuss problems later, I'll tell you in each problem the keywords and how to identify. Don't worry about that. Okay, but let's discuss now for this problem. How you will identify this is a DP problem. Okay, now you need to do one thing. Now the stairs are n is 5. So you need to reach till 5. Now here also you have choices, na? Either you can take one step or two step. So you have choices. You have to choose. So whenever you have choices, yes, that is kind of uh, it's kind of a DP problem. Or later you can optimize recursion using DP also. So one way is I will only take one step, then again one step, 1. So 1 plus 1 plus 1 plus 1 plus 1 plus 1. 1, 2, 3, 4, 5. Till 5 I can reach. Or maybe first 1, then 2, then again 2. Or maybe first 1, then again 2, then again 1, then again 1. But first 2, then 1, then 1, then 1. So there are many possible solutions. So we can't figure out something like this. Let's just write down all the solutions. It's not possible. What we do is try to write it as a function. See, think about this. Either you can try to solve from here, like suppose we are at 0, or let's start from here. So let's start number of ways to reach till 5. Ways 5 is I'm writing, or you can simply write f of 5 also. But to give you a better understanding, because here we are finding number of ways, that's why I'm writing this. But when we code it out, I'll write some other name also, other name only. Okay. Ways 5 means number of ways to reach till 5, till here. So can I write number of ways to 5 is 5 at 5 is what? Because you can take one or two steps. So if you know number of ways to reach till 4 plus number of ways you know to reach till 3, then you can add these two and you can find out number of ways to reach till 5. Yes, I think, yeah, you can apply your common sense and that's the answer. Yes. So number of ways, can I write number of ways to reach 5 is equal to number of ways to reach till 4 plus number of ways to reach till 3, because you have to identify all distinct ways, all distinct ways. Okay, you can take one step or two step. So if you are here, so basically if you are going down, so one step down, if you take one step means 4, you will reach to 4. Two step if you go down, then at third you will reach. Okay, or you can apply something like this. You are at 0th, you can take one step or two step, so you will reach to 1 or 2, either this or this way, in whichever you are interested or you are comfortable, you can go parallelly. I'll explain these two. Okay, but whenever I code, I'll just take this approach because I'm more comfortable in this. In uh, this, it's kind of more like Fibonacci series. Okay, now let's understand this first. So number of ways, can you identify number of ways? It means number of ways to reach till 4, number of ways to reach till 3. But have to find out now number of ways to reach till 4. If you know number of ways to reach till 3 plus number of ways to reach till 2, because we can take one step or two step. So you have choices, one step or two step. Two choices you have at every stage. So 3 number of ways to reach to 3 plus number of ways to reach to 2. If you know these two, you can do addition of these two and you will get number of ways to reach till 4. Same 3, just minus 1, 2, minus 2, that is 1. Yes. So number of ways to reach till 3 is equal to reach till 3, to reach till 1, 2, 3, here. If you know number of ways to reach till here and to reach till here, total number of ways. So you can add these two and that will be this thing. Number of ways till 2 plus number of ways till 1. Yes. If I say you can take only one step, do you need this thing? No. It's clear that you can take only one step. You don't have any choice. So you are at 0, just take one step, you will be at 1, then 2, then 3, then 4, then 5. So there is only one way you can reach till 0 to 5. Or you can something like this also draw. Number of ways to reach till 5 is what? You can take only one step. So obviously you will be at 4, then only you can reach till 5, only one step. Then 3, then 2, then 1, then like 0. Only one way. The tree is something like this. When you have choices, you have choice now. You can take one step or two step. That is why at every stage, you can take one step or you can take two step. You can take one step, then you will be at 2 or you will be at 3. Like that. Okay. That's why tree is something like this. Yes. Now, for 3, to reach till 3, if you know number of ways to reach to 2 and number of ways to reach to 1, you can add these two and you can get total number of ways to reach till 3. Okay. Now, if you want, you can stop here. Base conditions are when n is 1, because it's given, you can take one step or two step. So when n is 1, there is only one way. So when n is like 1, you have only like one step here. N is 1, you are here. You need to reach till here. N is 1. You need n steps to the top to reach till top. Means one step. So you simply just jump just one step and that's it. You can't take two steps because n is only 1. So that's base condition. When n is 2, means something like this. You are here, 1 and 2. You need 1 to 2 steps to reach till top. Means you take 2 steps. You want to reach here. It's given. So how many ways are there? You know, directly you can jump 1, 1 or directly jump here. So 2 steps. 2 ways are there. So when n is 2, there are definitely 2 ways. So these are base conditions. Simple. That these are given in the question. Okay. So these are base conditions. When we reach till n, when n is 2, that's base condition. Means how many ways are there to reach till 2? 2 ways. How many ways are there to reach till 1? 1 way. Okay. Or if you want to make it more look like Fibonacci series, it's okay. You can explain, you can just move further like at 2. I'm not taking base cases, these two. These can be base cases or either one is this or you can write now one step downward. So at 1 and 0, 1 and 0, 1 and 0, 1 and 0. So you will take base cases as when n is 0 and n is 1. So when n is 0, n is 0 means simply here means n0 means you don't need any steps to reach till top. You are already there. N is 0. So how many ways are there? Do nothing. It's like one way. You can say it's really you jump there only. That's it. Okay. Don't write here 0. There is one way. If n is 0 means you are there only. N is 0. There is no steps. There are no steps further. So you are at that place only where you want to reach. So just jump there only. Only one way. So only one way. And when n is 1, same thing. Like you are here and n is 1 means in one step you can reach till top. Total number of steps are 1. So you just jump. How many ways are there? Just one way. You can take only one step. So 1. Either you can take these two base cases. Now it's up to you. In whichever you are comfortable or you are more, you can say intuitive for you, you can write these two base cases or these two base cases. Okay. So how to write down this thing now? That's nothing but it's like Fibonacci series. Can you simply write it? Yes, we can simply write. We can take a function like maybe climb stairs and you will be given int n. Let's write here. Climb stairs and int n. Suppose n are given to you. N means 5 is given to you. Okay. So what we do? We recursively call climb stairs for n minus 1 plus climb stairs for n minus 2. Like that. And return. So recursively we are calling. But base cases you need to write here to stop this recursion. Base cases are I'm taking if n equal to 1 means return 1. If n is 1, there is only one way to reach there. If n equal to 2, then return 2. There are two ways. If n is 2 means this and this, 1 and 2. Total 2 steps you need to reach till top. So how many ways are there? Either you can take one step, then one step, or directly you jump there taking 2 steps. That's given. So it will return 2. These two are base cases. Otherwise, we just call this recursively. That's how you can think about this. Now, okay, it's recursive. So at every step, you have two choices. Two choices. So time complexity will be 2 raised to power n. Time complexity of this recursion is generally have to find out time complexity of a recursive function. Number of recursive call into time per call. So time per call is, just check this. We are having simple one if this, so constant time for this, constant time. This is nothing but recursion. So time per call is constant, so it's order of 1 into total number of recursive call. How many recursive calls are there for int 5? For 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. Okay. When it will be 6, 7, 8, 9, 10, so it will be exponential. You can check out this thing and draw this tree for n is equal to 6, for 7, 8, 9, 10. So it will be almost 2 raised to power n. So that's 2 raised to power n. So total time complexity will be 2 raised to power n. When you submit this on Leetcode, you will get TLE error. Okay. When the output is large, if constant is given, that output is till maybe 40 or something like this, 40, 45, then you will not get any TLE error. But if allowed is output is in 10 raised to power 8 or 6 or kind of that, then you will get error. Now think, yeah, that's recursive problem, but why it is DP? Are there sub problems which are overlapping? Are you calculating same sub problem multiple times? Yes. See, here 3, you are calculating it. Here also 3, you are again calculating it. Number of ways to get to reach till 3, you are calculating here. Number of ways to reach till 2, you are calculating. You are again calculating here. You are again calculating here. You are again calculating here. So yeah, there are sub problems which are repeating. You are solving multiple times. So that is overlapping substructure. So you can optimize it. Now means you can apply here DP. How to optimize it? We know that's normal Fibonacci series kind of thing. So whenever you are finding number of ways like this, just store the result. Store the result. And later, if you are using the same subproblem, rather than calling, use the same result. Rather than calling, use the same result. So number of calls in that case will be order of n calls. So in that case, time complexity will be n into order of 1. So that is order of n. Almost polynomial, maybe 2n or kind of that. But when we ignore the constant, so it will be order of n only. It will drastically decrease number of recursive calls. Right? So that's a DP sign. That yeah, it's a DP problem. Third is, can you solve this with bottom-up approach? Don't use recursion. Directly fill the table. Directly, it's kind of like table means it's 1D DP problem, 1D pattern. 1D pattern. So I will write like 1D DP pattern. Because I've told you now, in DP, at every stage, we have to take some decisions. And decisions we can take when we have data. So DP prepares or generates data, tabular data. And from that data, it decides and find out the best solution. So like this, we can say explore all the feasible solutions and pick the best one using DP. But that tabular data is, in this case, it's 1D DP problem, 1D. We just need only one array. So how this is 1D DP pattern? See, 1D DP pattern means DP of I at that array I, it depends on previous values. Here, same thing. It depends on previous values. This depends on previous values. This depends on previous values. This depends on previous values. Okay, that's what we can identify. It's a 1D DP pattern. So you need only 1D array. Simple. We solve problems having tables also, like 2D. Don't worry about that. Okay. Now pause the video and you submit it on Leetcode. So we have to complete it. Climb stage. Same as Fibonacci series. Pause the video and you submit it yourself. With normal recursion first. So simply write down here, if n equal to 1, return 1. And if n is equal to 2, return 2. When n is 2, there are two ways to reach till 2. Otherwise, simply return climb stairs till n minus 1 plus climb stairs and n minus 2. Just add these two and return. See, it's with normal recursion. Let's run this and see. Accepted. Maybe you will get TLE error. I don't know. Let's see. With just normal recursion. So yeah, we're getting this error now. Because when n is 45, obviously, there will be many 2 raised to power 45 calls. So time limit exceeded. Okay. Oh, it's okay. Modify this. We know we can optimize recursion. We know it's a DP problem. So we can optimize it. Yeah, best way, optimize it. So we'll take first array. I'll name it DP only. I'll just call a helper function, that is recursion, help recursion. We are passing n and this DP here. Okay. So let's cut this thing from here and define this helper. This time two things we are passing. So two parameters, n and DP array. Same here, two base cases. Then, or you can fill it if you want, arrays dot fill this DP with -1 values. First you have to fill it. So after creating, just fill it, and whatever this will return, I'll simply return whatever this helper function return. Base cases. Okay, now we check if already we have that value, if we have already solved that problem. So we'll check DP of at this n. If it is not equal to -1, means we have solved that. So return from here that value DP of n. No need to call recursively these things. Otherwise, call these things, change the value at dpn at this array first, store the value, and then return. Then return DP of n. Simple. That's it. That's how we optimize it. I hope it works. Let's run this and see. So accepted, and let's submit it. I think this time this will not give TLE error. It will be submitted. Okay, again you are getting TLE error. Why? So let's see your code. Okay, sorry. The thing is, because we are calling climb stairs the same method recursively, but we have to call this helper rec. Method name is helper rec. So just change it. Please make sure you don't do this mistake, because now the recursive is this method helper rec. This is not that recursive method. Okay. Now submit it and see. Okay, sorry. The thing is, because you have to pass here two parameter. One is DP and one is n. So n minus 1 and DP as well. Let's run this. Accepted and submit it. We optimize it. So that is DP we have used. It's like top-down approach, recursion plus memoization we have used. Now directly, can you change it with to bottom-up approach? Don't use recursion, just use iterative. Because here also we need only previous two values. Till n, if you want to reach, so we need previous two values, that's it. Simple. And you know base cases. So we start from the smallest problem smallest solution and build the solution step by step. Same as Fibonacci series. Pause the video and you update, you try it out. Use that tabulation method, bottom up DP approach. I hope you have done this. Let's comment out this. There we need DP array. Yes, we need DP array. Let's fill it with -1, or I think no need to fill this with -1. Directly we can fill this with at 0th, it's 1. At 1, it's again 1. Or because base cases we are taking 1 and 2, so let's take 1 and 2. For 2 it's 2, for 1, yeah, it's 1. But what if you give it to 0? Because okay, that is fine, you have done that. You don't have to call this. Now we run a loop. I is equal to 3 and I less than equal to n and I plus plus. Because we know at 1 and 2 what are the problem statement, what are the value. So till from 3 will run. Okay, let's run this. So dp of I is equal to dp of I minus 1 plus dp of whatever I minus 2 value, just add these two. And at last simply return dp of n. But the thing is, now see, it will not work. That is the only code for now. But it will not work. Let's run this. Okay. Okay, return. Sorry, it's always I make this mistake. Return, yes, spelling mistake. Return spelling mistake. But still you will get error. See. Okay, these two cases are accepted. But if I submit it, let's see what happens. Runtime error. Index 2 out of bound for length 2. N is equal to 1. Okay, when you give n is equal to 1, let's see. Let's try run this. N is 1. So this n is 1. I'll just write down here n is 1. N equal to 1. So we'll pass 1. Array will be created of size. Size is equal to 2. 1 plus 1, that is 2. So we have index. Index is equal to only 0 and 1. That's it. But you are at index 1, you are putting 1. At index 2, you are putting 2. But there is no index 2 for now. Then that's a edge case when n is 1. If suppose n is 0, in that case also you are creating a dp with size 1. That in that case size will be 1, index will be only 0. So there also you will get error. If n is 2, then size will be 3 of this dp array, then index will be 0, 1 and 2. Index will be 0, 1 and 2. Okay, then that's fine. 1 and 2 we can write down, and I3 this will not be true. So dp of n, whatever at 2 we will return, that is 2. That's fine. But when n is 0 and when n is 1, have to handle those situations here. Okay, you can handle those things also. Simply write if here n equal to 0, return 0, and if n equal to 1, return 1. Right? Let's see it works or not. Accepted and run this. So yeah, we are done. And see, if you think if n is equal to 0, equal to 0, because we have discussed there, if n is 0, then return 1. Because n is 0 means we are at the same place. We don't need, there is no n, there are no steps you need to take. You are at the same place. So just jump there only, do nothing. So there is one way. That will also work. Return 1 here rather than returning 0. You submit it. Let's submit it and run this. So accepted every case and submit it. It will work. Both are fine. Especially in this case. Right? But when you take edge cases 0 and 1, here I am taking edge cases 1 and 2. But if you take edge cases 0 and 1, same as Fibonacci series, and see what happens. So you can change it, I guess, because we have already done this here. Same edge cases over there. So same code is there. It's not different. So that's your assignment. You check it. Change the base cases to 0 and 1. And if you're more comfortable in 1 and 2 also, you can go with these. But at least you try out edge cases 0 and 1. That will also work. Okay. Now, yeah, we have done this. But can you more optimize it in terms of space complexity? Yes, because we need only previous two values. So like this, we have optimized here, taking just two, previous one, previous two, and just current, only 3 variables. Just run the loop and that's it. Change it and it will be all set. So now I'll not do this thing because we have already done this thing in this Fibonacci number. It's exactly same problem. It's your assignment. Now you little bit more optimize your code in terms of space complexity. Don't take this DP array, just take 3 variables and solve it. But you have to do it yourself now. Okay, it's your assignment. So I guess you get it. How to solve it with recursion, with top-down approach, with bottom approach, and how to identify that this is a DP problem. These are really important, these steps. How to identify that it's a DP problem. You can apply here DP, but that thing will come to you when you solve more and more questions, right? That's the 1-2 question we have done. So to somewhat, I guess it is clear to you. You have to find out you can apply here recursion or not. Then are these overlapping subproblems? Means in the recursion, if there are 2 calls, then these are overlapping subproblems. Can you store the result? If yes, then yes, that's a DP problem. You can use memoization, then bottom up. Try to apply, then bottom up. Okay, then again optimize space. Okay, so space complexity, time complexity, it's order of n. Space complexity, order of n, because you are taking DP array. If you don't take DP array, it's order of 1 space complexity. Okay, now that's it for this lecture. Now we'll see the next lecture with one more DP question. Till then, bye bye. Take care.